This video is to help with the binomial Excel file. I have it here, geometric and binomial distributions Excel file. So let me download that. I have two different distributions on this one. The one on the left is for the geometric distribution. The one on the right is for the binomial distribution. And we'll mostly use this binomial distribution here. So one other thing I want to show you in the reading in section 6.2, there's this table here, which is very helpful for taking English and translating it into math symbols. So the phrases are here on the left, and then the math symbol is over here. It does take a little bit of practice to get used to making the connection between these two, but this is a good table to have in your notes as reference when you're doing problems involving really any type of discrete probability distribution. Now let's look at a couple problems. 6.2.41 here. It says 14 jurors are randomly selected from a population of 3 million residents. Of these 3 million residents, it's known that 40% are Latino. Of 14 jurors selected, 2 are Latino. So what's the proportion of the jury described as Latino? We're just taking 2 and divide by 14. That gives us 0.142857. And we'd round to 2 decimal places, so 0.14. Now, part B is calculating a probability that 2 or fewer of the 14 jurors are Latino, thinking that they came from this population where 40% are Latino. We can use the binomial distribution in this situation. So if we go to this file, we're using the binomial distribution, and the probability of success is 40%. So we'll put 0.4 in there. Number of trials are the number of jurors that were selected, in this case 14. And we're looking for 2 or fewer. So 2 is the number of successes, and 2 or fewer would be less than or equal to. So you have to put the first less than symbol and then the equals symbol and press enter. That gives us the probability that it's 2 or less. And here, the 0.03979, that is this probability right here. So for 2 or less jurors that are Latino coming from, if they're saying it came from this population, that probability would be just under 4%, which is a pretty low probability. There should probably be more Latinos in the among the selected jurors. And that's what this last question is asking. So it's unusually low. We can also solve some other problems with the binomial distribution in looking at the mean of the distribution and the standard deviation of the distribution. They have specific formulas which you can find in the reading. The mean is n times p, and the standard deviation is the square root of n times p times 1 minus p. The Excel file does these calculations for you as well, so I want to show you where those appear in this file. So it's saying 47% of adults believe that the overall state of moral values is poor. So that probability, that 47%, that's our probability of success in this case, if we're looking at people who believe that statement. So I'll put 0.47 in there. Number of trials is the number of people that were selected, in this case 350. And since we're looking at the mean and the standard deviation, we're not really looking at a specific number of successes, so we could just leave that as it is. But we want to look lower on this Excel file to the expected value, in this case 164.5, rounding that to 165, and the standard deviation here 9.337, so on. We round that to 9.3 for the standard deviation. Okay, and then here, interpret the mean for every 350 adults, the mean number of adults you'd expect to believe that statement is about 165. And then this last one, would it be unusual if 152 of the 350 adults surveyed believe that the overall statement, overall state of moral values is poor? So 152 it's within one standard deviation of the mean, so not really too unusual. You could even, if you would want, like 152, you could put that as the number of successes. Typically when people say that, like 152, they'd be saying like 152 or greater. It's a pretty big probability there, so 91%. So yeah, not a very uncommon value. Could also look at, this is going to be a lot smaller, but let's just look at the probability of exactly, 152. That's 1.7, but typically when people say a statement like this, they're saying 152 or more, which would be common. Also, just within one standard deviation, so it's a pretty common value.